up, we have Chris Trump, who's joining us today. He's the guru of all gurus when it comes to Korean natural farming. So we're super stoked to have him with us today. I guess he's there he goes.
Hey Steve, thanks for having me.
Hey, how's it going?
Yeah, glad to be here. What a cool conference, and props to you guys for making it all free for all these people. What a cool thing. It's I was thinking about it during 2020, and everybody's stuck inside and started getting hay fever. And in Hawaii, a bunch of these musicians did these like mini concerts at their house where they all jumped on, and it was all free. Jack Johnson participated and all these cool Slacky guys, and it was probably one of the coolest like online venues I think I've experienced. And this has that feel, just dudes jumping on and saying, here's what I got. And yeah, so props to you guys for making that happen. So I am not a cannabis expert or a aquaponics expert. You guys are the cream of the crop here. I actually learned from Mr. Leonard Wilson way back in the day on the Big Island when I was producing lettuce with my cannabis, kind of our facility, what we built. And so my experience in aquaponics is kind of small scale systems. But really for me, what aquaponics is I was already deep into asking microbial questions for our farm in Hawaii, which was it is a macadamia nut farm. And aquaponics was kind of a shoe into the microbiological world for me. So much playing with microbes, and then right from there jumped into natural farming. So the yeah, I have a great deal of love for aquaponics as a result. And so I wanted to talk a little bit about my experience, some of my journeys, actually some of the work I did in the third world with aquaponics and still kind of participate in. And then a little bit of kind of how to, if you wanted to have a side hustle of food, how to quickly market that. But really, main thing I kind of want to bounce around, and Steve, maybe if you're willing to jump in and kind of dialogue with me on it, is I want to talk about a battery of biology that we can do with ongoing kind of brew of, if you will, a side reservoir for microbial inoculation for your aquaponic. So we'll jump into that in a little bit, but yeah, I built a small commercial aquaponic system to as a big question on whether or not we were going to crop diversify on the Big Island into aquaponics and lettuce production, and or ginger production, which in hindsight we probably should have done, but we didn't. We were going to do probably we were going really big. It was going to be basically about 10 acres of surface area, really, of aquaponics, and we had it laid out. And in the end, we decided to go with natural farming and macadamia nuts, making things better. But the journey for me in food production, getting that, you know, making money was a lot of fun. So for those that might have a side hustle of food with their aquaponics system. Obviously, cannabis is going to be bigger dollars per pound, but if you're turning and burning with some of these food products, you can challenge your income on aquaponics. Just throwing it out there. Lettuce and tomato production is definitely viable for that. So what I did is I took what I could produce, which was at that time mustard greens, baby romaine lettuce, rainbow chard, and a few other things. And I took it down to the local produce vendors, and I had all gallon Ziploc bags of my produce, and I said, here's what I can produce, here's my number. I'm taking it to all your competition, and I didn't say it like that. I say I'm taking it around to a few produce vendors today, and give me a call with what you think you can, what you would like, and what you'd like to pay. And I got a call that that baby romaine lettuce for $6 a pound was a go with one producer or one produce vendor. And I said, okay, I switched all my production over to baby romaine, not deciding what I was going to produce food wise until I had a buyer and the price I wanted. So with that baby romaine lettuce, I was able to produce on a little 40-foot, 40-foot troughs. So I was able to produce 100 pounds a week of baby romaine lettuce, which is $600 a week for one person running an aquaponics system, which in the end was a bit small, or kind of the economy of scale was about break even, basically to pay my wages. But get out of workman's comp and all those things, insurance, if you're just a private person, $600 a week for, producing lettuce, the amount of work isn't full time. So pretty doable. And you could definitely get more than $6 a pound for that baby romaine. I loved in the tropics, Bambi by Johnny Seeds was a dope cultivar. It's my favorite. So tasty in aquaponics. I miss that actually. So I also played with doing aquaponics so in the end we sold that system, got out of aquaponics and stayed in natural farming for macadamia nut production, but still definitely love aquaponics for so many reasons. And one being that much of the world is abandoned parking lots. And in China, abandoned parking lots becoming aquaponic systems has become a thing. It's pretty beautiful in Nepal, rooftops in Kathmandu. Our aquaponics production facilities are springing up and gaining popularity as it is, and they're using airlift pumps for small systems to move the water because it's such a low energy draw. An air pump is a drastically lower energy draw than a water pump, and so these guys are able to spend less while producing something that brings income or food. And so that's stuff I've been playing with some people I work with that do third world education. And it's a lot of fun because those spaces are not usable for food production in soil. And so I love aquaponics for a lot of reasons, and continue to learn. Talking to Steve and listening to his podcast or video cast has been a lot of fun. Here's a little system. share my screen. Here's a little system we built in Haiti in like a week or 10 days. It was concrete troughs. We nailed it down to the sides with concrete screws. Had a gravel, system. But these are hanging PVC cutouts to put the little pots in. But this system's still running in Haiti and producing food in the community. They produce all kinds of things in there. I think they most love the fish production.
Do you have the screen open on your screen? Because we just see the folder.
Oh, you cannot see it? Sorry. I don't know why that's not working. Resume share. Can you see it now?
No. Maybe just try
hold on.
Screen instead of window, maybe.
Yeah, I got it. Now?
Now it's working. Looks good now.
All right, here, let me start over. Sorry, thought you were seeing that. So that is, concrete troughs. Those are half PVCs with cutouts. They did a bunch of little 2-inch pots and gravel bed. And cool team knocked this out really fast. The first time around, they ate all the fish. Just didn't even wait for the plants. Just went fishing and enjoyed a good fish dinner. So we replaced the fish, and now they produce a ton of food. Those are the guys that run it. They still run it. This is about 10 years later. And this is up in the hills in Haiti, near Hench. I have come to believe that aquaponics in the third world is a bit of a stretch, because the skill to run it and the learning curve is a pretty big hurdle to overcome. Is that coming through there, Steve? You guys can see that all right?
Yep. There's the play controls are on the screen. I don't know if that's possible to move, but
oh yeah. Is that better?
Yep.
And so the solid settling, sump pump, and just a standard aquaponic system. Super fun to build, and super cool that it works for this small community to have, food production, and they produce a ton of fish. Because it's so hot there, the tilapia go ballistic, and them having clean water to grow them in, it works quite well. All right, I am going to pause share and come back. All right, can you see me again?
Yep.
Sweet. So taking it over, if you wanted to take your expertise with aquaponics and share it in places where food is needed, I think it is very viable. It's very doable. And at the same time, some of the hurdles are definitely going to be translation, expertise. Yeah, and we can jump into questions. But
I was just queuing them up there for you so that when we get to that, we have them queued.
Awesome. The yeah, there's definitely hurdles to producing food in the third world with aquaponics, and really it comes down to the things that you don't know, that people don't know in the places you might go, and the things that they don't have access to, or the kind of intuitive challenges, the things that seem intuitive to you. So I've done a bit of that, and totally cool, still happening in a lot of places around the world, but definitely has its challenges. And I've leaned since to soil production. And in Kathmandu, in Nepal, there is no soil access for much of the people that want to grow food, and so aquaponics has become the sole kind of food production tool for small farmers, and they're using rooftops. So aquaponics saving the day in Nepal. Yeah. Last thing, kind of, that I knew there'd be a bit of questions, and good to dialogue about microbes and aquaponics, and we can get into that. Oh, I looked forever before I get into the microbes of the kind of talking about a microbe reservoir. I looked forever for a good picture of the system I use to grow ginger in aquaponics, Steve, and I couldn't find it. I talked about that briefly in the aquaponics seminar a while ago, and I don't think I have retained a picture, but here we go. This is me producing mugwort, and you see over here, can you see my cursor? No. Over here in the corner, tucked away, can you see the cursor? Not at all.
Yeah, we can see it.
Okay, yeah. So the that plastic basket is what I use. So here I'm growing mugwort in some of the beds, but that plastic basket is what I use to produce ginger in aquaponics. And I wish I had a better setup or picture of it all in production. But these baskets were filling basically where these floating beds are. The basket would be, and I would screw them in to the side with supports, 2x4 supports, and raise them up so that they were totally out of the water while the ginger was producing, with some shade cloths covering them. And that is upside down right now, but black plastic netting or mesh would hold the soilless media, and I produced about 200 pounds per basket per year, with no work during production. So planting is work, filling the basket, and then harvesting actually was extremely easy, much easier than harvesting in soil. You just dump out and rinse off a bunch of perlite and vermiculite, and that was yeah, it was an incredible way to grow ginger, and protects it from a lot of the problems that ginger runs into, like nematodes, etc. So yeah, they don't float. There's too much weight in them to float. So those little arms there are needed to physically lift and lower. And you can create just a lift and lower system by screwing into the side here. And anyways, I loved that. It could definitely be improved on. If somebody wanted to tee off on root crop vegetables produced in aquaponics, that is something I used in the past. Yeah, so the thoughts I've had in natural farming, we produce liquid IMO, soil microbes in a liquid brew system, just like an actively aerated compost tea. The key there is that you never brew longer than 36 hours. because you get this rise in microbe production and then it falls off. However, and another reason we don't produce using the same inoculant, people ask, hey, can we take a little bit out of there, stabilize it and continue to brew with it? And the answer is no, because in soil farming, we don't want to skew for aquatic microbes. But if we wanted to maintain a population of diverse microbial life, where the aquaponic system might ebb and flow or destabilize, having a aquatic inoculum. Steve's done some really great work harvesting IMO2 in an aquatic version. I think we can do more trials with that and continue to play with it. But harvesting microbes out of functioning aquatic systems, like a great estuary or good marshland or something like that, is a great way to get diverse microbial communities from soil connected waterlands or water systems. And the curiosity that I have and what I would encourage that we play with is, what could we perpetuate? Could we have a microsystem going on continually with diverse microbials alongside our aquaponic system that has a lot going on, a lot of fish and a lot of plants and soil that might skew our microbial diversity over time as things fluctuate? Could we get a stable slow drip into our aquaponic system? Basically a tiny little aquarium size stable aquatic food web environment where everything is geared for or cared, that everything we do is for the microbes to have stability and food and self-perpetuation. And then just a drip emitter that allows a little bit of that water to slowly go into the aquaponic system to help with stability for microbes. That's kind of the thought I had, Steve. What do you think about that?
Well, they utilize something similar for reef tanks. I mean, that's essentially what a refugium is, and a reef tank is a place for your aquatic, food web to live, and your isopods and other things that can feed your coral and other things like that. So I'd never thought about putting it in an aquaponic system, but that exact application is already done in other forms of aquaculture, which I think is an interesting idea. You certainly could have it where you had everything, breeding at a higher rate. I'm just trying to figure out how you would maintain it at that accelerated food web rate.
Well, you don't even need
that much different.
You don't need to have it accelerated necessarily, as long as that was your stable place, so that it could help with kind of alleviate or stay away from fluctuations that naturally come in aquaponic systems. Anyways, that was the talking about water. Again, I haven't experimented with aquaponics for several years, but I know liquid IMO is a great resource for aquaponics. You can brew it, apply it, spray it to your plants. It helps with diverse microbes getting established, and you can just do that. The base natural farming recipe, I have a YouTube on how to do it. It's quite easy and simple, and that takes 36 hours, and you can brew that anytime you need that, and that already exists, and people use it for aquaponics and introducing and reintroducing good diversity in microbes. But if there was a what did you say the words used in salt systems? Refugium
So in a reef tank, they call it a refugium.
refugium. Yeah. So could there be a good use for a refugium in aquaponics with diverse, basically IMO or aquatic? Could you create a stable mini tank to slow feed your whole system, where that could potentially keep you from those microbial fluctuations?
Well, the thing that first comes to mind is that aquatic plants actually have a whole separate microbiome that lives only on the surfaces of aquatic plants, because a lot of aquatic plants can actually mineralize and uptake nutrients through their leaf tissue separately, the same way that normal terrestrial plants do through their roots. They can actually absorb it directly through their stems and leaf tissue. So they actually have microbes that are adapted for that, that might be separately beneficial than what would be in an aquatic environment alone. I think that that's certainly an area where I could see doing something like a chop, the same way that you would, chop and blend fresh kelp, doing something like that with maybe like your fresh, grow some type of aquatic plant that has a large surface area, and then take that and make a tea or a quick blend from it, or blend it and then use that as an inoculant, might have some unknown beneficial effects on the root system. That it's certainly a biological diverse a web that I have not had a chance to really experiment with the way I would like to.
Well, the whole point of chatting about that briefly is just in case there's some more super nerds out there that want to get a better idea than refugium and bring it into play. I would love to hear any ideas that come off of that, because it would be a fun thing to know about, even though I'm not currently playing with it. Should we do some questions, Steve?
Yeah, I was gonna say we got a lot of questions from chat for you, so I would like to maybe hit this first one real quick. LIMO is best used for foliar in soil or in the soil of the root zones. I actually really like adding it for the mineralization tank. So where you take your fish waste and you brew that up, that's really where it's going to have its most largest impact, because it's going to break down that fish waste and provide and help fill in gaps that you would otherwise have in your aquatic food web.
Also, the foliage of whatever you're growing is a great place for that liquid IMO to go, because you're going to get interaction on leaf surfaces that are unique, that happen just there. And so I would like to also see it getting on your plants foliarly, and that dripping off the plants, and that marriage of what's growing on your plants or the inoculum of your plants themselves is one of the main benefits of liquid IMO. Is just that, basically, just like we're protected by our skin biome, plants have that same protection that occurs, and you'll get some of that leaching into the system just from the dripping into the root zone, no matter what kind of system you're running. But yeah, a big dose of healthy and diverse microbes into your biofilter, or wherever you got your bulk of fish poop, like Steve said. That's where you're going to get a ton of repeat benefit. Nutrient cycling, basically processing your nutrients into the various things.
We had another question. Have you used lactobacillus or other ferments for honeybee feeders to help benefit honeybees?
Yes, and I can give you the bee recipe right now. It is a specific recipe, and what you do is you provide it, you provide it in a reservoir that they have access to on demand, in addition to their water. So you don't replace their water with it. You provide it in addition to their water. And if you have let's see, how many, I need to, Okay. It's 1 to 300 BRV. Yeah. Do you have a hope you have a notepad. I'm just gonna spit this out. Maybe I'll type it out and put it in chat. Would that be better?
I'll leave it up to you, or if you could type it out and just throw it on the screen, it might be easier, just in a notepad, so people can have it to screenshot.
I just went looking for it, and what I have is in a calculator that has all the math figured out for me. So
Or just type it in chat.
let's say in a gallon. We'll say in a gallon. Here we go. I will I'll do this. We will screen share it. And so in a gallon, we'd want about a ½ ounce of brown rice vinegar, and we want a very small amount, 1/10 of an ounce of LAB. We want 5 ounces of seawater, 1/10 of an ounce of OHN, 1/10 of an ounce of calcium phosphate, and mineral A you don't have, so you can just up that seawater to like 10 ounces. But it's 1 to 25 seawater, 1 to 800 LAB, 1 to 300 vinegar, 1 to 800 OHN, 1 to 800 calcium phosphate, and 1 to 1,000 mineral, which the same mineral that's in there is in seawater. So yeah, put that in your water. And so what you would have is, here, I'll draw it. Good question. Bees love this. Another thing that's really great for bees is if you inoculate under the hives with IMO. In tropical places, in Hawaii, for example, we deal with rove beetle, which is destroys hives, and rove beetle has a soil dwelling stage. And in that soil dwelling stage, they're actually really susceptible to IPMO or fungal predators. And so if you have a functioning fungal ecosystem under your beehives, maybe in the grass or whatever, you don't have rove beetles. It's really wonderful. We did that with we do about 150 hives in Hawaii, and all of them are inoculated underneath. But you just have your hive. They have their water, and then you'd have their nutrient as a optional. Very rudimentary drawing here. So you got your nutrient off to the side. They have their access to their water. In the nutrient, you want to fill half of it with rocks, or cut in half corks, or something that they can stand on, because obviously they will drown if they don't have a perch to drink their nutrient. Yeah, good question. I hope that's helpful. I could type that out if that was too fast for people. You got another one? Question?
Yeah, this is from Caleb, who was just talking. Are you experimenting with any new IMO inputs, or sorry, KNF inputs, or any new inputs in the style of KNF thinking? If so, is there what new possible inputs are you playing around with? And then he also asks, how did you get so cool?
No, it was a pretty cool talk, that last talk. I think you guys have a pretty smart community there. Definitely always playing with new things. I think a lot of what I end up playing with now is customizing or fitting natural farming to different industries. So I'm working with the wine grape industry. giant row crops with huge mechanization tools, and really taking the essence of natural farming and making sure it works with the efficiencies they already have in place or the needs they have. So, you know, inexpensive remote brewing systems for multi-site liquid IMO applications in wine grapes where there's hills, all different places spread out, and they need applications regularly, but they can't be driving a whole bunch of water all over the place. So we did these tote system liquid IMO brewers that were really inexpensive, with just aeration through really specific amount of holes in PVC. And we were getting pretty good results with brewing out microbes, and a pretty simple system, just a good air blower. And that's been pretty cool, fun tech. New yeah, I can't think off. I'm sure there's something new that we're playing with, and for some reason off the top of my head, I'm not thinking of anything like new and exciting. A lot of customizing natural farming for different scales and types of operations, including third world scenarios. What were we going to say, Steve?
I was going to say, do you want to touch on IPMO? I don't think not everybody has heard of that one yet, and you're the one that turned me onto it.
Sure. Yeah. So in Hawaii, one time I had a batch of my substrate that I grow out in IMO3 get full of weevils. And I was full go mode on the farm. We're farming 750 acres of macadamia nuts, and I needed to produce my IMO3 that day. And I was like, man, I can't run. And I don't think the weevils are really going to hurt anything. Produced my IMO3, and all my little weevils turned into these little white puff balls. And brewed liquid IMO with that, sprayed it out on the orchard. And my orchard walkthrough, I saw some of my some of my pest beetles, these green stink bugs, as white puffballs. They were there in my orchard, covered in fungus. And I said, that's interesting. What happened there? And so that caused a deep dive of research on who eats beetles in the fungal world, and realized that a lot of what eats beetles, a lot of these fungal predators exist in nature. They're abundant in nature, but not necessarily everywhere. And so by cultivating multiple collections of IMO2 and then growing it out on this chitin or carapace rich substrate, which was my weevils, we produced a kind of predatory fungal rich liquid IMO, and that caused pressure on my pests. Since then, Steve's played with it in Zimbabwe multiple times. I played with it in California, actually just a couple months ago here, and different people have played with it, and so far it's only anecdotal, in that we haven't done any peer review studies, but the idea is that we are taking in any place we are, and by putting chitin or the exoskeleton of bugs into our IMO1 for rice, and Steve's work in Zimbabwe, he thought that the insect frass going into the rice when you put it out was actually the best or most successful. And because then that natural environment, wherever there is a chitin eating fungi, they're going to move in and chew on that. And so you're kind of collecting or putting out a trap for those fungal predators and go after beetles. But the cool thing about that, what I like about that, is wherever you are in the world, you can seek to cultivate fungal predators for beetles without having to go find an expensive bottle of, Bavaria bassiana or something like that. You can cultivate your own fungal predators for beetles, and use it, have it as a shelf-stable inoculum, which is pretty amazing in that IMO2 process, and then brew it in liquid and spray it on your crops. Steve, you had a remediation with grasshoppers, right?
Yeah, we were mainly focused on large arthropods, so we were able to knock back the grasshoppers, and we actually repeated that here in Oklahoma as well this year and last year. Again, similar applications, and what we were doing is applying it not only to where our plants were, but the whole field around it, the walkways, the area around it. It's a general area treatment to introduce those bacteria and fungi back into that area, and it's nice because you don't have to worry about it running off into the local stream because it's just a species that's already present in the environment. You're not going to create a gross imbalance in your ecosystem because you're not harvesting anything that wasn't already there. That's a very ecologically responsible way to handle it, and something that I think really has a lot of potential for things like Africa and the Caribbean and other places that don't have the money, or it takes me 40 to 45 days to get stuff to the farm at Zimbabwe if it's not in country, right? So it's just, I'm sure it's even worse now. So, it's just logistics alone, it helps reduce the issues. The one thing I will say is it can go after your bees. So do not spray it if you have stuff with a lot of flowering sites or something that you intend to have actively pollinated. I would be careful utilizing it right around the flower structures because it will infect bees. I have observed that at a small scale. Not a huge die-off or anything. It didn't wipe out the hive, but we did find some that were dead on the ground in the same field as our applications.
So to speak to that, I think the bees are going to be at risk of getting applied onto. So if you spray them, they're at risk. Bees are actually pretty capable of cleaning themselves. Anyways. That process of visiting flowers, etc. They do a pretty good job of kind of self-care. So bees are going to be, I would venture, this is my best guess, and I think an entomologist would be better to speak to the absolutes, but that bees are going to be most at risk of being sprayed directly or being coated or knocked down by this. Whereas if it's in your environment, it's been a few days, your beetles, most of them are going to have a ground dwelling stage or a time where they're in the ground. They become extremely susceptible, whereas bees are going to be able to kind of stay above it, if you will. But yeah, spraying a hive is going to be probably problematic.
Awesome. We have, let's see what other questions we have here in the queue. Has Chris experimented using sheep and goat milk instead of cow milk? And does it make a difference for lactobacillus?
All milk works. Even that stuff that you don't have to refrigerate works. Bean milk works. Powdered milk, rehydrated works. It all works. Coconut milk does not work very well. So a lot of the plant-based milks, there's limited success, but all your animal milks, human, etc., all of it is successful.
And if you're a cannabis grower and you're doing the plant-based labs, you can actually make vegan cheese, which actually is legal to do medicated legal cheese in the US. You can't do dairy-based, but you can do non-dairy based. So it is a legal way to make infused cheese or medicated cheese if you are looking to do it.
And if you are doing vegan, really, really successful with a really great cheese, garbanzo beans. Garbanzo bean milk is very successful, beautiful curd. Yeah.
Also awesome for gluten-free pastries.
There you go. Soulshine asked, could FAA possibly harbor fish pathogens? I will defer to you, Steve, but my thought would be very unlikely because of the process, this 1-year breakdown process. There is very, very little for them to go on if there is a pathogen, and the outcompeting that's going to happen with the inoculation of IMO into a properly made FAA is going to consume a lot of kind of non-symbiotic materials.
Well, the only pathogens you really have to worry about getting from your fish would be like streptococcus, tuberculosis, E. coli, and salmonella. Would kind of be the big four you'd be concerned about, but all of those would not be able to handle that long-term environment that you have in that FAA process alone. Better yet, all the other, again, microbes. In fact, there's quite a bit of research now, and you're going to see some published stuff here in the next year or two around lactobacillus being used for food safety. Specifically, we're treating non-human pathogenic E. coli in living aquaponic systems. I myself have used it to treat 3 separate systems that were commercially operating for non-human pathogenic E. coli. We're able to treat them with labs and have it be undetectable after 30 days of treatment. So, and it might be 2 weeks, we don't know, but we were able to get it completely to 0 with just 30 days worth of treatment at a 1 to 1,000 dosing ratio in the system. So it's not even like we're doing anything beyond a normal maintenance dosage. It's just, having the right microbes present eliminates that, that issue. So, and I truly think, 5 or 10 years from now, you're going to see lactobacillus dosing, required for food safety protocols for aquaponic and hydroponic systems, because of how well it can outcompete many of the pathogens that do make us sick. So I think that's definitely something I really look forward to.
I really hope that, LAB treatment becomes a part of food safety throughout the entire system, through the whole food world. We have these water sorters in macadamia nut production, and they can get funky, and there's a worry that they can produce mold or foster, and it's like a little LAB in that recirculating system and you have no issues. It'll keep things clean, and it's like that's, but we got off as humans onto pasteurization being the way for food safe things, and really we need balance eventually. Question from Gingerbug: I would love to know more about the differences in inoculation methods between aquaponics and soil. And I think that by and large, there's very little difference to inoculate aquaponics and soil as far as you're bringing it in or just introducing it one way or another, and it has a life of its own from there. So a small amount that then goes and can self-perpetuate. The idea in both systems is that we're introducing something that does well in that environment, or that is good for that environment and therefore thrives. And so both systems, a little goes a long way. And Steve was talking about it being a great place to put a liquid IMO, being the settling tank, or the place where your biofilter, where your fish poop builds up, and in soil being the drip line, or the area around the plants where they eat, being the most bang for your buck kind of application spot. But when I look at treating soil applications, I look at treating the whole acre, meaning I want the top of the tree or the top of the plant, the stem of the plant, the soil around it, the grass in the borders. I want everything to be touched. And I think in aquaponics, generally, if we have good going in as an inoculum, we would want the whole system kind of touched by that. Would you agree?
Oh yeah. Yep. No, and there isn't a huge difference as far as inoculating. Maybe slight differences in dosing and things like that. Or also be mindful when you dose labs into aquaponic systems, it will bring your pH down 0.2 to 0.3. parts. So be mindful of that. It can be beneficial because then you can go ahead and add a little pH up to add a little nutrients, calcium carbonate or potassium silicate, or you can use that as an organic certifiable pH down. Labs is absolutely allowed in organic certified systems. It's been approved at many different facilities now. And you absolutely can use it as a natural way to have a pH down for your, whatever solution that you're working on.
And if you are going to add LAB for aquaponics, you can take a small bit, a little bit, and put it in a 5-gallon bucket with some brown sugar and aerate it overnight. And if you're trying to get a big kind of clarification, or you wanted to process a bunch of food, getting it, keeping it isolated, putting it on some food overnight with some air, and we get a lot more kind of immediate multiplication, whereas sometimes it can kind of disperse and pitter out if you just put a tiny bit into aquaponics. So that is one way to cause your LAB to go a little further if it in fact is a limited resource for you. Maybe you're not making a ton at a time or something like that. So that is something that has been played with in Hawaii a bit in aquaponics to great success.
Another question here. How is IMO quantified post-application? Do you have a way to classify different IMO collections? And then how do cultures know that they're applied are properly, I guess, the beneficial? And you've talked about this quite extensively. You have a great talk, long format talk on this. It's about 40 minutes on your YouTube channel as well. But do you want to answer that one? It's definitely a question I hear a lot.
Yeah. So quantifying what is established, if we were looking at species, etc., would require DNA mapping. That is a project I am continually working on with any and all universities that will partner, or any doctors that are connected and can do that DNA mapping. This is the question I'm asking: how best can we quantify what we're moving from your indigenous soil environment to final establishment in our farmland through the IMO process? 1, 2, 3, 4 establishment. What is the diversity lost? How best can we foster maximum diversity in that transfer and permanent establishment? I want to ask that question as much as you do, in a very much mapped and documented scientific manner. That said, I can speak to what we know about how nature works without that data all in my pocket. We did a project with MIT to ask those questions due to some unique circumstances with the doctor that was running it. That pittered out and there wasn't enough money to restart it. So we got a few bits of data on bacteria from a sample here and there, and they never mapped the fungi. So that was really disappointing. That was a lot of work. It was a really cool project, and nothing to show for it. But indigenous microbes. So in our local environment, once we get a bloom of your positive, what we see and know as large hyphal diameter fungi, big, 4 micrometers or bigger fungi growing out on substrate and then growing out in our ag land as a result of application. For example, we can have ag land that we do a microbial analysis before. This is one kind of way. It costs about $100. It'll be $200 for a farmer. You do a full kind of microbe lab, send it off to your favorite microbial lab. I use Earthfort often just because they're convenient and easy, but there's a bunch of great microbe labs, and you send them off. and get a good snapshot. I did that actually just right here with a grass hay farmer. This is my website, Steve showing, thanks. I did that here with a grass hay farmer. We did their before microbial analysis and their after microbial analysis to see what level of introduction and establishment we got over 2 years. And it's a great way to know just how well you establish diversity, you know, what kind of fungi, etc. And yeah, so that is one way if you want to spend a little money. Otherwise, just getting good collections from indigenous places. We already know, especially if it's an untouched 1,000-year-old untouched space, we already know that those microbes like your temperature, your barometric pressure, your rainfall, your altitude, and so they're going to self-perpetuate in that soil as long as you don't destroy or disturb them.
Awesome. Well, thanks so much for coming on, man. How can people find you? It's been an awesome hour of education with you.
Yeah, thanks for having me. I am on Instagram at Soil Steward. My website is christrump.com. You can search Chris Trump on YouTube. And I am, if I can get it together to finish a little bit more video editing, I am adding my final 10 hours of content to my online class. And with this addition, I feel like it is a complete educational package to really get you started, but not only started, really introduce the understanding of all that's going on in natural farming and how best to use it. So that's available online on my website at christrump.com. And November, end of November here, I forgot the date offhand, but we have our first live Q&A for all those online students. So we'll jump on a Zoom call together and be able to just dialogue with everybody's unique scenarios, kind of like this, but private, just for natural farming students of that online class. So thanks, Steve.
Thank you.
Yeah, this is a great spot. I'll keep watching.
Awesome. Well, thanks a lot, and